In illustrating a pesticide calibration, we will not repeat procedures for determining wetted area, pivot travel speed, and outer wheel track circumference. Assume a producer has a second 122-acre field under a center pivot. He has a pest problem that will require applying 2 pints of pesticide plus 2 pints of oil, a total of 2 quarts of pesticide per acre. The producer, therefore, needs 244 quarts of pesticide to make the application. The pesticide product label directs the user to dilute the pesticide concentrate with 7 parts water to 4 parts pesticide concentrate. To find the amount of water diluent needed, we divide the pesticide quantity, 244 quarts, by 4, then multiply by 7. The amount of water diluent needed is 61 times 7, or 427 quarts. After adding that amount of water to the 244 quarts of pesticide, the producer must apply 671 quarts of pesticide water solution, or 167.75 gallons. The chemical label recommends a water application depth of 0.3 inches. Again, assuming an estimated efficiency of 85%, 35 hundredths of an inch of water needs to be pumped to net a 0.3-inch water application. The total acre inches of water that needs to be pumped is found by multiplying 0.35 inches of water times 122 acres. A total of 43.1 acre inches of water are needed. Assume that the well serving this pivot delivers only 725 gallons per minute. Again, divide by the 450 gallons to the acre inch per hour constant. This well can produce 1.6 acre inches of water per hour. Next, we need to find the revolution time needed. This is calculated by dividing the number of acre inches of water needed, in this case 43.1, by the produced capacity of the well, 1.6 acre inches per hour. We determine that it will take 26.9 hours to apply this amount of water. The percent timer setting to make the 26.9-hour revolution is estimated by dividing the revolution time at the 100% setting by 26.9. We will assume that this pivot, like the one in the first example, completes a revolution at the 100% setting in 19.2 hours. Doing the arithmetic, the initial trial setting should be 71%. The last step is to determine the injection rate for the pesticide. We know that 167.75 gallons of pesticide oil water solution need to be applied. The pivot revolution time will be 26.9 hours. By dividing the amount by the time, we find that 6.24 gallons need to be injected hourly. In order to measure the injection rate using the calibration tube on the injection system, we must convert this number to either milliliters or ounces per minute. Gallons per hour is converted to ounces per minute by multiplying by 128 and dividing by 60. An injection rate of 13.3 ounces per minute is needed. To convert to milliliters, multiply 6.24 by the constant 3.79 liters in a gallon, then multiply by 1,000 milliliters in a liter, and divide by 60 minutes in an hour. The injection rate in milliliters, therefore, is 394 milliliters per minute.